Hello everyone, welcome back to Nated Engineering. We are still doing heat engineering science N3, and today I want us to look at an exercise which is a question from a question paper that was written on the 17th of November 2016. It's question number 5, and we're going to start with 5.1. It reads as follows. A homemade geyser with a volume of 200 liters of water is heated from 293 Kelvin to 87 degrees Celsius by using coal. The calorific value of the coal is 26 megajoules per kg, and the specific heat capacity of the water is 4.187 kilojoules per kg degrees Celsius. And then they say, determine the following. 5.1.1. The temperature change of the water. 5.1.2. The quantity of water required to heat the water. And then question 5.1.3. The quantity of coal required to heat the water. So this is the information that we are given. We are given mass. They said the volume is 200 liters, and we know that 1 kg is equals to 1 liter. Therefore, since here we are more interested on the kgs, so that is why I put it down as mass being equals to 200 kg. So we are given the mass, we are given T1, and T1 is given to us as 293. There is a formula that you need to know, which is Kelvin is equals to 273 plus degrees Celsius. Kelvin is an SI unit of temperature, the same as degrees Celsius is a SI unit for temperature. The difference is that when you are given a number in Kelvin and you want to convert it to degrees, okay, let's say you are given a number in degrees Celsius and you want to convert it to Kelvin, you have to add 273. So if you have Kelvin, you want to convert to degrees Celsius, and then you have to take the Kelvin and minus the 273. This is the formula that you have to know, which is what happened here. We were given these 293 in kelvins, and we said minus 273, which we got our initial temperature, which is T1 as 20 degrees Celsius, and we're given T2 as 87 degrees Celsius. The calorific value or the heat value is equals to 26 megajoules per kg. The specific heat capacity of water is 4.187 kilojoules per kg degrees Celsius. So we are going to start with the first question. We're asked to calculate for the temperature change of the water. The change in temperature, which is 5.1.1. Change in temperature, that could be better, is equals to T1, is T2 rather, minus 1. Therefore, it will be 87 minus 20, which will give us 76 degrees Celsius. And then we move to 5.1.2. They say calculate the quantity of heat required to heat the water. The formula for heat, we said, is equals to M times specific heat capacity times temperature change. The mass we have is 200. The specific heat capacity we are given is 4 times the temperature, which is equals to, the change in temperature is equals to 67 rather. And from here, we are going to calculate, and I got the answer as 56.106 megajoules. I'm sure we do know how to convert from mega to kilo and all that stuff. So I decided to convert this answer because it was too long to megajoules. Then we move on to the last question. They say, calculate the quantity of coal required to heat the water. So to get the quantity of coal, we are going to use the heat value, which is the amount of heat energy that we are expecting from the coal when 1 kg of it is completely burned. This is the total heat of energy that we received from the coal. So what we are going to do is, for this question, we are going to say the mass of the coal. They say the quantity, which is the mass. The mass of the coal is given by the total amount of heat energy that we got from the coal divided by the specific or the heat value, the calorific value of the coal, which is 26 point, no, it's just 26 megajoules. And from here we get our answer as 2.158 kg. This is the total amount of heat energy that we got, and we know that per kg we get 26 megajoules. So what we do is that we say the total heat energy that was received, and we say divided by the heat energy that we get per kg. That will tell us how many kgs of coal we used for heating the water the water according to the question. And that is our question for 5.1. We move on to question 5.2.
5.2 reads as follows. An object with a total mass of 1,500 grams and a temperature of 85 degrees Celsius is placed in 2,200 milliliters of water with a temperature of 20 degrees Celsius. So now we can see that the object is placed inside the water, and we can see that the object has a high temperature compared to the water, meaning heat energy will be lost from the object to the water. The final temperature is 25. That is the temperature of both the water and the object that we are dealing with. And then they say determine the type of material used if the specific heat capacity of water is 42 kilojoules per kg degrees Celsius. So here they are asking us to determine the type of material, and for us to be able to determine the type of material, we will use the specific heat capacity. There is a table that they include when they ask questions like this with a question paper. It comes with a question paper, and it has types of materials and their specificities. So here we are going to calculate for the specific heat capacity of the material, and then go to that table, look for the object that has the closest value of specific heat capacity to the one that we calculated and find. So to get the specific heat capacity of the object, we're going to use the heat energy lost by the object is equals to the heat energy gained by water. So we know heat energy is what? Mass times specific heat capacity times change in temperature. Mass times specific heat capacity times change in temperature. We have everything here except for the specific heat capacity of the object. So this will be the mass of the object, specific heat capacity of the object, change in temperature of the object, and then this will be of the water. So we are going to substitute the mass of the object. We forgot to go through the values that were given, or the data. Its mass, which is 1.5 kg. We're given 1500 gram, but we need to convert it to kg because that's how we use it. For water, we are given 2200 milliliters, so we are going to convert to liters and then to kg because we are using it in kgs. And the temperature, the final temperature of both the water and the object that we're dealing with when is equals to 25 degrees Celsius. So we're going to substitute 1.5 times the specific heat capacity times the temperature change, which will be 81 minus 25 is equals to the mass of water, which is 2.2, specific heat capacity 4.2, times the change in temperature is 25 minus 20. And then from here we are going to divide both sides by 1.5 times 81 minus 25, both sides. And that will give us a specific heat capacity that is equals to 550 joules per kg. And then what we are going to do now is to take that value that we have, we go to the table, look at the value that is closest to the one that we got. You can see from that table that it is the specific heat capacity of steel. We got 550 and the specific heat capacity of steel is what? Is 500. So that is the value that is closest to the one that we got. 5.3 reads as follows. use the steam table to calculate the total enthalpy required for 1 kg wet steam for each of the following cases at the pressure of 1400 kilopascal. So when we are dealing with questions involving steam, we will be working with something we call the steam table. The steam table contains almost everything, if not everything, that you need to perform questions in steam table. So the structure of the steam table is something like this. It is a table. It has a column for pressure. The next one is saturation temperature, which is the boiling point. It has Vg, which is the volume. We're not really that much dealing with volume at this stage. We have HF, and then we have HFG, and we have HG. We don't need to worry about those others, SF and SFG, or SF and SG. We are not using it at this point. So in this question, you are given what? The pressure. What happens is that we are going to have a pressure that we are working with. Let's say they are given 1400 as they did in this question that we are dealing with. So what you are going to do is you are going to go to the steam table, find that pressure, and then you can place a ruler. Every value that corresponds with that 1400 is the value or are the values that you will be using when doing questions. So for example, you want to calculate for the enthalpy of wet steam. We know it is given by what? HF plus XH FG. So what we are going to do is we are going to go to the steam table, look for that pressure, and extract the value of HF, which will be here, extract the value of HFG, which will be here. In that case, the dryness fraction you will be given, and then from there you can do the. And you must know that the SI unit of these enthalpies in this table are kilojoules per kg, meaning we are dealing with 1 kg of mass. So if they ask you to calculate for the enthalpy of wet steam, and they say the mass of that wet steam, they say is 2 kg, you are going to perform the calculation naturally as we will normally do, and then at the end of the answer you are going to say times 2, because you want the enthalpy of 2 kg, and everything that we have from the steam table is of 1 kg. So let's continue with the question that we are dealing with. We are given a pressure of 1400 kilopascal. And we are also given what? The mass, which is 1 kg. And we are asked to calculate for what? Question number 1, 5.3.1. They say calculate determine the wet steam with a dryness fraction of 0.94. So 5.3.1 H wet is equals to HF plus X HFG. We go to the steam table and look for the value of HF. According to what I got, the value of HF is 830. The dryness fraction we are given as 0.94 times the value of HFG. We go to the steam table again and look for the value of HFG. And what I got is 1958. And then from here, we can calculate for the value of H wet, which I calculated and got that it is equals to 2670.52 kilojoules per kg. And then we go to the next question. They say the dry saturated steam at that pressure. What is the dry saturated steam? We know dry saturated is represented by Hg. So this is a matter of just going to the steam table, extracting the value and putting it here. And at 1400 kilopascal, the value of Hg is equals to 2788 kilojoules per kg. We go to the last question. They say total heat of superheated steam if the temperature of the superheated steam is increased by 240 degrees Celsius and an average specific heat capacity of 2.85 kilojoules per kg degrees Celsius. Use the boiler pressure as 1400. We're not changing the pressure, so we are going to do the last question. What is the formula to calculate superheated steam? Superheated steam, H sup, is given by Hg plus C sup, which is the specific heat capacity, in bracket T sup minus Ts. We are still using this pressure. So we go to the steam table, we extract the value of Hg, which is this one. Plus, from the question they are saying total heat of superheated steam if the temperature of the superheated steam is increased by, and the average specific heat capacity is 2.85. 2.85 is our specific heat capacity. And the temperature is increased by 240. So we do not need to know the superheated temperature and the saturation temperature, because these give us the change in temperature, which is exactly what they are giving us when they are saying is increased by 240 degrees Celsius. Therefore, we're going to take the 240 degrees Celsius and put it in here. And then this according to my calculator, will give us 2916 kilojoules per kg. And that is how we go about answering this question. Remember, when you are extracting values from the STEM table, extract the correct values, because once you miss a value, you are going to get wrong answers, whereas you know how to perform the calculations. So it's important that you use a ruler, if you have it, to check the answers or the values that are aligning with the pressure that you are using. That is all I had for today's video.